British Isles. An emerald set in a silver, well, in this case, a rather black sea. Over hundreds of millions of years, a wide variety of geological events have left a huge store of materials in the ground waiting to be exploited. Beneath our feet, there are a wide variety of rocks suited to all sorts of purposes in the construction industry. And all we have to do to get at them is to remove the soil and surface rubbish. What we've got here is a geological map of Britain, simplified, but showing most of the important strata. And many of these have got characteristics that make them excellent building stones. For example, the Jurassic limestone has been used for hundreds of years, all the way down the Cotswolds, and is still being quarried today in Bath.
It's cut out using the technology originally developed for coal mining, appropriately enough, as the stone is quarried underground. This stone has given Bath its honey gold appearance. The Roman baths and the Georgian buildings this town is famous for are all built out of it. One of the great benefits of this stone as a building material is that it is a freestone. It can be cut or worked in any plane, and so can be fashioned into complex and intricate decorative forms. It can even be turned on a lathe. Another limestone building. Winchester Cathedral, in the process of being renovated. The newly refurbished tower gives a clue to the cathedral's original appearance when it was built 900 years ago. But a lot has happened to it since then. The limestone is being dissolved by the acid rain that falls on the cathedral. The damage isn't just cosmetic. The fabric of the building could be threatened. Block by block, the cathedral is being reskinned with limestone.
Check it with you straight that way.
Painstaking and meticulous work, the only way to ensure the future of the building. The cause of the problem hasn't gone away, though, and it is likely that these self-same blocks will have to be replaced again in the next 100 years or so.
Try the bottom as you guys come out and then...
And again, this limestone is a freestone. The blocks can be cut in any direction with equal ease to make exactly the shape and size required for any part of the cathedral.
Those are obviously very specialized examples. The use of stone worked by traditional methods to preserve part of our national heritage. Now, in this country, we use much less natural stone in ordinary buildings than we used to. All around the world, a huge variety of stones are being dug out of the ground for use in buildings. And to see examples of that, we have to go elsewhere.
Erquy, a fishing and tourist village on the north coast of Brittany, France. The quay is a good example of the first thing to be thought about when choosing a rock for a building purpose. It must be strong enough. The quay is made of quartzite, a sandstone that has recrystallized, making it extremely tough. And it can be split in any direction. even across the original bedding plane. Another freestone that can be worked into the desired shape by stonemasons, although there's little difference between these blocks and the raw lumps that are found lying around the quarry where they came from. It's tough enough, it's called armour stone, but it's not pretty.
Here's the next stage of the Urquhart story. From exactly the same geological formation, this particularly attractive building stone. And what makes it so is this very fine colour banding, more or less parallel to the bedding. But the special feature here are these beautiful florid shapes, which can be recognised in this stone wherever it's been used. In engineering terms, it's exactly the same as the armour stone, but the colour banding makes it highly prized as a building stone.
And this mixture of the engineering and the aesthetic has been put to good effect in Urquhart. From small-scale blocks to lintels 5 metres wide. These blocks from the so-called Urquhart red beds are derived from a rock which was originally laid down in conditions very similar to those of the armour stone and subjected to the same processes of recrystallization. The iron banding is the difference that makes one valued as a building stone and has sparked the imagination of the odd architect. The rock is quarried locally. As it is relatively high in value, it's done on a small scale and traditional labour-intensive techniques are used. 2 men operate the whole enterprise, selecting rock which shows most commercial promise. Clear signs of the iron banding. In this case, following the lines of the original sedimentary layering. The method of splitting the rock is as simple as it is old. Wedges. It's called the plug and feather technique. They're inserted into pre-drilled holes, one of the few concessions to modern technology, and hammered home. Once the hammering has started, it must continue until the process is completed, or the rock may not split evenly. The plugs open the feathers, slowly cracking the rock down the line.
Je dis la même chose, pareil. C'est très mal, c'est mal fondu. On va recommencer.
Gradually increasing tension like this should split a freestone along a plane. And the rock starts to split, but badly. The dog-leg fracture line is the telltale sign of a flaw inside. The fracture should be a straight line, and the slice should simply fall off the block, like a slice of bread. This piece will be worth a lot less than they thought. And there are the 2 diagonal flaws in the rock that caused the irregular split. It won't make a lintel, but will be broken up into smaller blocks. Most of these blocks will end up in new buildings. But it isn't simply a matter of using any old block. There is a surprising precision in their preparation. block may look square, but it isn't square enough. It could be machine cut, but it is hand worked to give a natural looking finish. It's part of a window which has been precisely specified by the builder. When they're finished, all the blocks must fit together exactly. Hence the precision. It's a much more meticulous process than building with bricks. Some houses are made entirely of the stone. They're not all to everyone's taste, but the commitment to building in stone is there. Some of the rock is sliced and given a rough hammered finish. It is then cut into small sheets and slabs. Again, the rock has to be without flaws, so it can be guillotined into regular blocks. These are going to find their way into prestige piazzas and pavements. What we're seeing here is a renaissance of the original use of these rocks. This was one of the first Erkey redbed quarries. For 100 years it was worked without a break. It was abandoned about 50 years ago. Almost the entire output was prepared in the quarry itself. The only machine in sight is the crane. The rock was split and trimmed by hand, producing cobblestones by the million. Flooded and overgrown, today they are a pleasant place to take a Sunday afternoon stroll. Hundreds of itinerant workers were employed, providing the muscle to shift and break the rock. What they produced was widely used. It was transported by boat to towns along the coast and even as far afield as England. In places, the cliffs themselves were quarried away. Now that the faces have been recolonized by plants, it is difficult to tell whether they have been worked at all. The old quay is the last tangible sign of the industry here. The closeness of the quarries to the sea made the stone an attractive proposition. With easy access to marine transport, towns up and down the coast could pave their streets relatively cheaply. And even now, the cobbles of Erkey quartzite can be picked out in towns and cities around Brittany, as here in Saint-Malo, 60 kilometers to the east. The telltale fingerprint of the iron banding showing its source. This is a familiar view of Saint-Malo for tourists who have used the ferry. It's a granite town. It's built on a durable, resistant promontory of granite, defended by huge granite walls, which in medieval times protected the buildings behind.
In 1944, virtually the whole of the centre of St. Malo was destroyed in a firestorm following the enemy attack. I'm standing about here. Miraculously, the block at the corner survived. And there it is now, exactly the same as in the picture. The one next door was largely destroyed, leaving a single masonry wall. And it's now been rebuilt to match exactly the one on the corner. And in front of me here, everything went, just leaving a masonry column. And there it is, 3 stories high, and many of the stones are blackened and reddened, and that's due to the fire. And the other clue to that being an original column of stone are the bright yellow lichens.
Rebuilding the city after the Second World War is just one episode in a very long tradition of building and rebuilding in granite.
Just the kind of thing that I'd expect to find in a medieval city. An old wall, a variety of rocks, all beginning to show their age, and they're all granites of one sort and another. But the nice thing about St Malo, the tradition lives on, and this very modern building here is built of exactly the same materials.
It's obviously a modern building, but it isn't incongruous in the town. It's an example of the way the locals have resisted the temptation to maintain St Malo as a museum. A brand new granite building under the walls of the old town, but certainly not medieval in style. But that's not all St Malo has to show us. On the quay outside the old town, there are piles of rocks. They are orderly piles of regularly shaped blocks which were carefully prepared. Still visible are the drill holes left from splitting them in the quarry. They're imports. St Malo has a large port, and these rocks have arrived by sea from all over the world. They're destined for other parts of Europe and stonemasons' yards in France, where they'll be prepared for use as building stones. They're all freestones. They've all come from quarries like this, where the scale is much larger than the two-man operation at Erquy. Approximately 1/3 of a million tons of granite has already been extracted from here. This seems like a large quantity, but in fact, this is a relatively small quarry and only contributes a tiny proportion to the global trade in such rocks.
There are a variety of sizes here. From the smallest I've seen, 3.5 tons, about a cubic metre, 5 tons up there. And about the biggest size that even modern machinery can handle is this chappie at about 20 tons. To give some idea of the scale of the operation here, this one importer alone handles about 50,000 tons a year. It's about 2,500 like this. Given the variety of sizes, he's probably dealing with 3,000 to 4,000 blocks. They don't look very pretty in this state, but they've all been chosen to be absolutely free of cracks, because it's no use spending a fortune shipping this stuff halfway around the world and then all the expense of cutting and polishing to find that what you end up with is a beautifully polished slab which the architect won't use.
All the rocks have an aesthetic appeal, which makes them worth shipping around the world and spending time and money bringing out the beauty of the stone. It takes the best part of a day of polishing underwater to finish a slab like this. This is the top end of the building market, where all these costly processes, diamond-tipped saws, for example, are used to produce a tailor-made product for a particular building. Any finish can be achieved. The rock can even be flamed. This gives the appearance of natural weathering. With the quarries of the world to choose from, and with this range of techniques available for preparing the rocks, architects can achieve endless effects. Anything is possible.
This is the most expensive rock in the yard, known here as Bleu Norvège, Norwegian blue. In England we call it larvikite, and this is a crudely cut face done in the quarry, but this rock is going to end up polished. And when it is polished, I call it Barclay's Bankite, because I find it round my friendly hole in the wall all over the UK. Something that I'm very grateful to the stone industry for is that they bring these magnificent rocks from all over the world and then put them on the front of shops down the high street so that we can all walk down the high street and see these amazing rocks. And inside the polished slices, you can often see features, the minerals, the structures that are impossible to see in any other way. A real geological bonanza.
And what of the rock we started with?
And here's the ultimate in Erkey red beds. It's polished, of course, just like a granite. And I can see all the details of the grain and the iron staining. This rock is so well cemented that it can be polished without any of the grains falling out. A very expensive process. But the result, just look at it. A magnificent rock with all the details of the iron visible. And this is going to end up on the surface of a prestige building, the sort of building that you'd want to stand and look at for hours. Now that sort of application is very different from where the Erkey red bed started out as roughly hewn building stones and cobblestones. And now engineering properties are much less important than aesthetic appeal. The people who cut and polished this rock effectively have produced a brand new physical resource from the Erkey red beds. And it's one that's ideally suited to the building needs of the next century.